podcast has to do with hydrates. And really for hydrates, you need to have a couple just pieces of terminology. And the first thing is simply, what is a hydrate? And a hydrate is any compound with attached waters. And lots of compounds actually are hydrates. A lot of things we've used in labs so far this year have been hydrates, and it's just it's kind of one of the ways that they function is they absorb water, and lots of compounds again just do this on their own. The other thing I want you to know is anhydride. And an anhydride, just from English, an or a means without or against. So this is simply the hydrate once you've taken the water off. Okay, so it's really any compound with no waters or without attached waters, but it's really just the opposite of a hydrate. Okay, so once we've removed the water, it's now called an anhydride. Okay, so this is what problems look like. And essentially, hydrate problems are empirical formula problems. We're going to say it's empirical formulas with compounds instead of elements. But they're really solved the same way, instead of elements. Alright, so the way hydrates look is something kind of like this. I'll highlight it actually. We have FeCl2, and then it's attached to some number of waters. And your task is going to be to determine how many waters is it attached to. Alright? And it can be any whole number. So it might be 1 water, 2 waters, 3 waters, 4 waters. Usually 12 or less. Alright? So it can really be any integer up to 12. And probably there's some oddballs that are even more than 12. But here's what the problem says. A 2.4368 gram sample of iron chloride, something hydrate, is dried in an oven. So if we're heating this, we're actually doing a lab with this where we put it over a Bunsen burner, but what's going to happen to our water? It's going to evaporate. Okay? It's just going to turn into the atmosphere that we're breathing. So when the anhydrous salt, and notice this says anhydrous, so the water has been driven off, and we're just left with a salt, which is an ionic compound, is removed from the oven, its mass is now 1.5592 grams. What is the value of X? Okay, so we're given two numbers. One of them we're going to use, and the other one we're going to use to get the number we want. Alright, so what is this the mass of? This is the mass of our salt. So I can start off and say, well, we have 1.5592 grams of FeCl2, and that is without the water. Well, how can we figure out how much water we had? Well, we know the mass of this thing at the beginning, and it was 2.4368 grams, and we know how much this mass was at the end, 1.5592 grams. So the difference in these two masses should be the amount of water that evaporated, and in this case it's going to be 0.8776 grams. Okay, so we're going to come over here and put 0.8776 grams, and this is going to be of water. So I have my two masses. In empirical formula problems, we're going to change masses to moles, and then we're going to divide by the smallest. And that's the same thing we're going to do with hydrates. So our molar mass of FeCl2 happens to be 126.751 grams for every 1 mole, and water is 18.015 grams for every 1 mole. So when we do this math, we're going to get 0.0123 moles of FeCl2, and down here we're going to get 0.0487 moles of water. So just like empirical formulas, you start with masses, change your masses to moles, and now we're going to divide by our smallest. And the smallest will always be your salt. Okay? So it's always going to end up being 1. And your water should be, again, some factor that should be an integer. You shouldn't end up with halves or thirds now, but it should be a nice integer. So this ends up being 1, this ends up being like 3.96 or something like that. So that is essentially 4. So we have just determined our value of x. For every 1 FeCl2, we have 4 waters. And this would simply be called iron chloride, or iron 2 chloride tetrahydride. And hydrate just is what the water is called. Okay? You don't need to worry about naming them, only finding out what x is. We'll have a lab on this. We're going to determine the value of x, and expect a question on your test or quiz that asks you for the value of x as well. But it's an empirical formula problem with compounds instead of elements.